Here's example 4 with using reference angles to evaluate trig expressions. Okay, so just like in the first 3 examples, the first thing we want to do is find the actual reference angle, but also like the first 3 examples, we already found this reference angle in a separate video, so we're not going to go through it again here, but if you want to see the details of how to do that, check the video description for this video, and there will be a link to that other video where we find this reference angle. And then you can check that out and then come back here if you want to know how to use the reference angle to evaluate these trig functions. Okay, so the reference angle is just pi over 6, and again, we won't go through the details here. But anyway, so, and we're also going to use this, and we talked about this in more detail with example 1. So if alpha is a reference angle for a given angle theta, then cosine of theta is the same thing as cosine of alpha up to a sine, SIGN, sign change, and this sign depends on the quadrant of theta. Okay, so that means where the terminal side of theta, what quadrant that's in. So anyway, we'll talk more about that as we do this example. So now we already know from a previous video that the reference angle is pi over 6. So let's go ahead and draw that. And again, when you find the reference angle, you will end up drawing this picture anyway. So x, y. And actually for 17 pi over 6, remember it was larger than 2 pi, so actually it's coterminal with 5 pi over 6. So what we could do is use a periodic property right away and just say, okay, since 17 pi over 6 minus 2 pi, okay, multiply that by 6 over 6 to get a common denominator. So that's 17 pi over 6 minus 12 pi over 6. So that's just 5 pi over 6, okay, just 5 pi over 6. So since 17 pi over 6 minus 2 pi is 5 pi over 6, and because cosine and sine both have period 2 pi, then what we could say right away is this is just the same thing as cosine of 5 pi over 6. And this is the same thing as sine of 5 pi over 6. Okay? So it's just a side note, we could say that right away. And that's nice because 5 pi over 6 is a nicer angle than 17 pi over 6. Okay? I mean 17 pi over 6 isn't bad, it's just a little bit large. Larger than we like to deal with. Okay, so 5 pi over 6, and also 5 pi over 6 is a nice angle on the unit circle that's labeled here, right? So anyway, we don't actually have to do this because it doesn't change the reference angle at all. The reference angle is still pi over 6, okay? But we kind of use this 17 pi over 6 minus 2 pi is 5 pi over 6. We use that when we find the reference angle in that other video. So anyway, continuing with this. So again, we don't have to say this, but it's not a bad idea. It's not, you know, it's correct. It's not a bad idea. It does help us a little bit. But anyway, so if we were to draw this now, let's go ahead and draw this. So 5 pi over 6 is over here. So here's our angle 5 pi over 6. But if you didn't think about 5 pi over 6, if you wanted to draw 17 pi over 6, you just go around one full revolution and back to here, and you would have 17 pi over 6. Okay? But the reference angle will be exactly the same thing, so it's all good. It's okay. Okay, so from here, we could talk about this in terms of either one of these. Okay, 17 pi over 6 or 5 pi over 6. It does not matter at all. Okay, it absolutely does not matter at all. So we could say, okay, 17 pi over 6 is in quadrant 2, right? It's in quadrant 2. Okay. So what can we say about the cosine and sine? So cosine is 17 pi over 6. Now if you're in quadrant 2, remember cosine corresponds to the x-coordinate on the unit circle. So to the left of the y-axis, x-coordinates are negative, so the cosine is negative in quadrant 2. Okay. And the sine, remember the sine corresponds to the y-coordinate on the unit circle. Okay. And if you're in quadrant 2, you're above the x-axis where the y-coordinates are positive, so the sine is positive. Okay. So again, we can think of this in terms of 17 pi over 6 or 5 pi over 6. Okay, let's recast this in terms of 5 pi over 6 because that's where we left off over here. Okay. So what's that going to change? It's going to change absolutely nothing. Okay, except the 17s become 5s. So 5 pi over 6 is in quadrant 2. So cosine of 5 pi over 6, maybe keep the blue at least. So cosine of 5 pi over 6 is negative, and sine of 5 pi over 6 is positive. Okay. So why did I bother going through that? I just want to point out to you that if you have coterminal angles, 17 pi over 6 and 5 pi over 6, for example, coterminal angles, it doesn't change anything here at all. Okay. The terminal side is exactly the same, so the angles we say are in the same quadrant. Okay. So remember, when we say the sine SIGN sine depends on which quadrant theta is in, what we really mean is which quadrant the terminal side of theta is in. Okay, that's a short way of saying that. So coterminal angles have the same terminal side by definition. So if you express this in terms of one of those angles, change it to the other coterminal angle, then it's all just exactly the same. Okay, so I just want to point that out there. And again, we didn't have to go through 5 pi over 6, but you know, why not? We did in the other video when we got the reference angle, so we might as well keep it consistent. So anyway, and remember, again, the reference angle is pi over 6, but we're not going to go through the details here because it's in that other video. Anyway, so since the reference angle is pi over 6, then what this tells us is that cosine of our theta is the same as, so our theta now is 5 pi over 6, or we could keep thinking of 17 pi over 6, does not matter. But it's the same as the cosine at our reference angle, okay? It's the same as the cosine of our reference angle. But remember, cosine of 5 pi over 6 we found was negative, okay, because 5 pi over 6 or 17 pi over 6, same thing, they're in quadrant 2, okay? So the cosine is negative, so that's why we take this minus sign, okay, because this sign, SIGN sign, depends on which quadrant theta is in. Since theta is in quadrant 2, the cosine is going to be negative, so we take the minus sign here. Okay? So that's going to be a minus sign. And then cosine of pi over 6 is root 3 over 2, so this is actually going to be negative root 3 over 2. I'm kind of out of room, I hate to go into here, but so this is negative root 3 over 2. Okay, so that's that. And then what about here? Well, sine of 5 pi over 6. So this is, remember, this is true for all 6 trig functions. It's not just cosine. Okay, we wrote it in terms of cosine, but it's also true for the other 5 trig functions. So it's true for all 6 of those trig functions. Cosine, sine, tangent, cosecant, secant, and cotangent. Okay, so then this equals the sine at the reference angle. Okay, and remember, the sine of 5 pi over 6 is positive. Okay, it's greater than 0 because we're in quadrant 2. So we don't take the minus sign. We just leave it as it is. Okay. Okay, so just leave that as it is, don't take the minus sign. So this is the sine of pi over 6, which is 1/2. Okay? So that's our answer for example 4 of using reference angles to evaluate trig functions like this.